Have you ever pondered on the question, what if you could be in two places at the same time? Welcome to the enigmatic and paradoxical world of quantum physics, a domain where your wildest imaginations can turn into stark realities. Quantum physics, an arena that defies our everyday logic, houses an intriguing concept known as superposition. This idea suggests that particles aren't confined to a single state. Instead, they can exist in multiple states at once, much like being in two places simultaneously. Consider a coin, for instance. When you flip it, it's either heads or tails, right? But in the quantum realm, this coin can be both heads and tails at the same time, until observed. It's as if the universe holds its breath, keeping all possibilities open until the moment of decision. So, in the quantum world, being in two places at once isn't just a possibility, it's reality. Welcome to a universe where the impossible becomes possible, and the extraordinary becomes ordinary. Quantum physics doesn't just challenge our perception of location, it also redefines our understanding of reality. This elusive field of study presents us with a myriad of peculiarities that boggle the mind and defy conventional logic. One such quirk is the phenomenon known as quantum entanglement. Imagine, if you will, a pair of particles that become inextricably linked. No matter how far apart they are, be it the width of a room or the breadth of a galaxy, a change in one particle will instantaneously affect its counterpart. This isn't just a theory, it's a proven fact in the world of quantum physics. However, this isn't simple action and reaction as we understand in classical physics. It's not like throwing a stone into a pond and watching the ripples spread outward. No, this is instantaneous, faster than the speed of light, which, according to Einstein's theory of relativity, is supposed to be the universal speed limit. Yet, here we are, with quantum entanglement, defying that very limit. This leads us to a profound and perplexing conclusion. Distance, as we understand it, may not actually matter in the quantum realm. What does matter is the relationship between these entangled particles. This relationship, once established, persists regardless of the physical distance separating the particles. But how does this happen? Well, that's where things get really interesting. The truth is, we don't fully understand yet. We can predict it, we can use it, as in the field of quantum computing, but we can't fully explain it. It's one of the many mysteries that make quantum physics both fascinating and frustratingly elusive. Our understanding of the universe is based on the assumption that cause and effect are linked by time and space. However, quantum entanglement throws this understanding into disarray, underlining the fact that at the quantum level, the universe doesn't play by the rules we're used to. So, in the quantum realm, actions do speak louder than words, and they can shout across the universe. So how does this quantum weirdness affect you sitting there watching this video, you might wonder? Well, the impact of quantum physics on technology, and specifically quantum computing, is nothing short of revolutionary. Quantum computing is a new type of computation that leverages the quirks of quantum physics to perform complex calculations at speeds that were previously unthinkable. At the heart of a quantum computer are quantum bits, or qubits. Unlike traditional bits, which can be either 0 or 1, qubits can exist in both states at once, thanks to a property of quantum mechanics known as superposition. This means that a quantum computer can process a vast number of possibilities all at once. Imagine trying to find your way out of a massive labyrinth. A traditional computer would try every path one by one until it finds the exit. A quantum computer, on the other hand, can explore all paths simultaneously, finding the way out in a fraction of the time. But it doesn't stop there. Quantum computers also employ another quantum peculiarity: entanglement. When qubits become entangled, the state of one immediately affects the state of the other, no matter the distance between them. This allows for an unprecedented level of coordination and communication speed among the qubits, adding another layer of speed and efficiency. The potential applications of quantum computing are mind-boggling. From simulating complex biological systems, to optimizing logistical problems, to cracking encryption codes, the possibilities seem endless. We are just beginning to scratch the surface of what quantum computers can do. But it's not just about speed. Quantum computing could also lead to entirely new types of algorithms and methods of solving problems, expanding our computational horizons in ways we can't even imagine yet. So while you're sitting there, watching this video, know that quantum computing isn't just a theoretical concept. It's happening now. Companies and researchers around the world are racing to build and improve quantum computers, pushing the boundaries of what's possible. Quantum computers could be the key that unlocks the next technological revolution. We may not know exactly what the future holds, but one thing is certain. With quantum computing, the future is now. And it's not just about futuristic technology. Quantum physics is already part of our everyday lives. Now you might be thinking, I don't remember signing up for any quantum experiments. But believe it or not, we all interact with quantum physics more often than we realize. Let's take a look at some everyday technologies that rely on the principles of quantum physics. First off, lasers. Yes, the same lasers that are used in everything from barcode scanners at your local supermarket to DVD players. Lasers work on the principle of stimulated emission, a quantum mechanical effect that Einstein first predicted back in 1915. And then we have the humble computer chip. These tiny pieces of technology that power our laptops, smartphones, and even our cars owe their existence to quantum mechanics. Quantum physics explains how electrons move through these chips, enabling us to design and create smaller, more efficient devices. Next up, we have MRI scanners. These medical marvels use the principles of nuclear magnetic resonance, another quantum phenomenon, to produce detailed images of the human body. Without quantum physics, we wouldn't have this non-invasive way to peek inside our bodies and diagnose a myriad of health conditions. Even the Global Positioning System, or GPS, that guides you on your travels, utilizes quantum physics. The atomic clocks that make GPS possible are based on the quantum mechanical properties of cesium atoms. Without understanding these quantum properties, our GPS systems would be off by several kilometers. And let's not forget about the LED lights that brighten our homes and cities. These energy-efficient light sources are another practical application of quantum physics, specifically the principle of electroluminescence. So even though quantum physics might seem like a complex and distant subject, it's actually working behind the scenes in many of the devices we use daily. From medical diagnostics to DVD players, quantum physics has quietly infiltrated our daily lives. But the quantum world is still full of mysteries waiting to be unraveled. As we delve deeper into the quantum universe, we stumble upon conundrums that continue to baffle even the brightest minds. One such enigma is the infamous measurement problem. In the quantum realm, a particle exists in all possible states at once. This is called a superposition. Yet when we measure a quantum system, we find the particle in one specific state, so the act of measurement changes the system. But how does the particle know it's being observed? And why does this observation cause it to choose one state over the others? These are questions that scientists are still trying to answer. Then there's the question of quantum gravity. Gravity, as described by Einstein, is the warping of space and time caused by mass and energy. But in the quantum world, particles also behave like waves, and there's no clear way to reconcile these two descriptions. This clash between quantum mechanics and general relativity is one of the major unsolved problems in theoretical physics. It's like trying to fit a square peg into a round hole. And let's not forget about entanglement, a phenomenon so strange that Einstein himself referred to it as spooky action at a distance. When two particles become entangled, they become interconnected in such a way that the state of one instantaneously affects the state of the other, no matter how far apart they are. This defies our everyday understanding of how the world works, and it's something that scientists are still trying to wrap their heads around. These are just a few of the many conundrums in quantum physics. Each one is like a piece of a vast, intricate puzzle that we're still trying to put together. And as we continue to explore this strange and fascinating quantum universe, who knows what other mysteries we might uncover? As physicist Richard Feynman once said, "If you think you understand quantum mechanics, you don't understand quantum mechanics." So where does this leave us in our quantum journey? We've explored the puzzling principles of superposition, where a particle can be in multiple states at once. We've delved into the enigma of entanglement, a phenomenon that connects particles across vast distances. We've peered into the future with quantum computing, a technology that promises to revolutionize our world. And we've found that quantum physics isn't just for scientists. It's at work in our everyday lives, from the sunlight that brightens our day to the technology that powers our devices. Yet despite these discoveries, quantum physics remains a mystery. It challenges our understanding of reality and opens the door to a world of possibilities. It's a journey that never ends because with every answer, a new question arises. Quantum physics may be baffling, but it's also fascinating, and the possibilities it presents are truly mind-boggling.